We're going ahead in Chapter 2 to Section 2. Chapter 2 is about equations, inequalities, and problem solving. Section 2 is more about solving equations. Our objectives are 1. To use more than one property of equality to solve equations. 2. To simplify expressions to solve equations. 3. Clear equations of fractions and decimals. And 4, identify identities and contradictions. We have solved simple equations by using properties of equality. We will now expand our equation solving skills by considering more complicated equations. We want to develop a general strategy that can be used to solve any kind of linear equation in one variable. Now we have a definition. A linear equation in one variable can be written in the form ax plus b equals c, where a, b, and c are real numbers and a does not equal 0. The reason a can't equal 0 is because if it's 0 times x, that'll make the x disappear, and a linear equation must have an x in it, or a variable. Use more than one property of equality to solve equations. Sometimes we must use several properties of equality to solve an equation. For example, on the left side of 2x plus 6 equals 10, the variable x is multiplied by 2, and then 6 is added to that product. So this problem says multiply x by 2 and then add 6. To isolate x, we use the order of operations rules in reverse. So if we multiply by 2 and add 6, we're going to go to the reverse. So we're going to subtract 6 and then divide by 2. First we undo the addition of 6 and then we undo the multiplication by 2. This is the equation to solve. 2x plus 6 equals 10. It's very important that you start writing very neatly, that you try to have all your equal signs in a straight line so you can keep track of these are all the left sides and these are all the right sides. We have to make sure at every spot that we're doing the same thing to both sides. 2x plus 6 equals 10. We're going to subtract 6 from both sides. So 2x plus 6 minus 6 turns into a 0. So 2x is now by itself. 10 minus 6 is 4. Now we have 2 times x. To undo a multiplication, we divide. 2x divided by 2 and 4 divided by 2. 2 divided by 2 is 1. So we're left with x, or 1x, equals 2. Our solution is 2. Here's another example. Let's look at this and think what's the order of operations and then what's backward. Negative 12 is multiplied by x and then 5 is added to that. So we're going to go backwards. We're going to undo the 5 and then undo the negative 12. To isolate the variable term, the term that has the x in it, we subtract 5 from both sides to undo the addition of 5. To isolate the variable x, we divide both sides by negative 12 to undo the multiplication by negative 12. So this is the step-by-step solution. We're subtracting 5 from both sides. Then the 5 goes away. This turns into a 12. Now we're going to divide both sides by negative 12. And our answer is negative 1. Let's check this. Negative 12x plus 5. We don't know if it really equals 15 when x equals 1. We're going to find that out. We're going to remove the x and put a negative 1 in its place. That's substituting. We're taking this negative 1 and putting it in the place of x. Negative 12 times negative 1 plus 5, does it really equal 17? A negative times a negative is a positive, so we have 12 plus 5. Does it equal 17? Yes, it does. So the solution is negative 1. The solution set is the set containing the number negative 1. Simplify expressions to solve equations. When solving equations, we should simplify the expressions that make up the left and right sides before applying any properties of equality. Often that involves removing parentheses and or combining like terms. Here are two examples. We'll work one at a time. A, 3 times the quantity k plus 1 minus 5k equals 0. Our strategy for both of these is that we will use the distributive property along with the process of combining like terms to simplify the left side of each equation. We're going to distribute the 3 to the k and to the 1. We learned about this in the first chapter. 3 times k is 3k. 3 times 1 is 3. So we get 3k plus 3 minus 5k equals 0. Now we have two terms containing a k. 3k minus 5k will come out to be negative 2k. Plus 3 is still there, equals 0. Now we're going to get rid of the 3 by it's being added. We're going to undo it, so we're going to subtract 3 from both sides, and we get negative 2k equals negative 3. Now we're going to finish by dividing both sides by negative 2. Negative 2k divided by negative 2k equals negative 3 divided by negative 2. Negative divided by negative is a positive. 2 over 2 is 1. And negative divided by negative is a positive, and we don't make mixed numbers. As we're doing algebra, we leave improper fractions unless it's a story problem. Now the PowerPoint is going to show us how to check. We are going to remove both k's. This is always how you check. Find the variables. You're going to remove them and substitute the answer that we got. So we removed this k and we got 3/2. We removed this k and we had 3/2. Now we're going to work this out. 3/2 plus 1, well, 1 is 2/2, so that's 5/2. And 5 times 3/2, when we have multiplication, 3 times 5 is 15 over 2. So we've got 3 times 5/2 minus 5 times 3/2. This equals 15/2, and this equals negative 15/2. Does 15/2 minus 15/2 equal 0? Yes, it does. So that is true. The solution to our equation is 3/2. The solution set is the set containing 3/2. Example B. Once again, we have to distribute. This is an example where it is so important to pay attention to signs. We have a negative 2 times a, which comes out negative 2a. We also have a negative 2 times negative 7. A negative times a negative is a positive. So this changes to 8a minus 2a plus 14 equals 68. Our next step is to look at both sides and see if anything can be simplified. Here we have like terms. 8a minus 2a is 6a plus 14 equals 68. Now, this is the term containing the variable. It's the last term we work with. We're going to subtract 14 from both sides. So we end up with 6a equals 54. To finish now, we're going to divide both sides by 6, and a equals 9. The solution is 9. The solution set is the set containing the element 9, and this PowerPoint suggests that you verify by substituting 9 into the original equation. I will continue with this in the next video. Thanks for listening.